Okay, welcome to MBF3C, Grade 11 College Prep Math. Uh, this is WASA Distance Education. I'm Pete, and I'm your teacher. So here we are in the last week of the course, and we're just going to keep going through the review that we started last Thursday. So I'm going to pick it up on lesson 11, lesson 3, unit 1. And we'll probably just wrap up Unit 1 and get into Unit 2 today. Now, as we go through this review, keep in mind probably the most challenging unit, probably Unit 1, I think, for a lot of students. So, if it seems like I'm spending more time on that, it's deliberate. Unit 2, maybe a little less so. Now as far as our schedule goes, today's Tuesday. We have Tuesday, Wednesday, and Thursday. Last week I mentioned that I wasn't sure if we're going to have all 3 classes. Well, we are. So the schedule is now set. Okay, so if you did have any questions, if there were some topics you weren't sure about, or some key questions that you needed to, that you wanted to see, then certainly feel free to let me know. You don't have to call in necessarily. Just let me know somehow, and I'll make sure I include it in the review. Okay. Now, as far as wrapping up the course, this is independent learning. It's we're supporting you with the lessons, with the broadcast, but it really is independent learning. So, if it's going to take you a little longer to finish the course, then certainly you have that time. It would be helpful if you let me know what you're planning, especially if you haven't sent in any work in a while. If you're working on a unit or something, just send me a note or Facebook or call me or even get your DEC to send me a note saying what you're up to. Some students I know I'm getting some work from you, so and that'll be fine. Once you've handed in all 20 lessons in a course, then there's a final exam, and that's what this preparation's all about. So, it could be that you're really not quite there yet, that you're still working on the course. So what I would suggest you do is after you get all your 20 lessons done, then review these last few lessons on the videos, either in the WASA archive. You go onto the WASA website and select archive. You can download them, or you can go to YouTube. It's PW space WASA, and either way you can get the video, and so you can watch this review. Hey, maybe you're doing that already. Okay, so well, we left off last week, and I'm just going to pick it up on. Actually, did I say lesson 3? I think I meant to say lesson 4 here. Just because powers seem to be, sometimes it's some topics seem to cause more difficulties than others, and part of it might be that the course material doesn't really give you a lot of support in some parts of this, right? So the exponent laws, lesson 4, unit 1. You were given 3 main exponent laws, and that was to deal with when you're multiplying or dividing powers, or when you're taking a power to a power. And then there were 2 special cases, negative exponents and 0. Okay. So really, and if you think about the multiplying and dividing powers, they have them divided up into 2 laws. But really, if you're multiplying a power with the same base, they say variables, it could be anything. Okay, if the bases are the same, when you multiply powers, then you add the exponents together. Okay, that's it. Now, what makes it tricky sometimes is when there are negative numbers in there. That can make it a little bit tricky. But you just have to solve the exponent part of it as if it was an algebraic expression. It is, right? So if you have negative 3 plus 11, it's going to be, what's that going to be, 8 or something like that. You plug it into your calculator is the other way to do it. Now, the sort of the complementary rule for powers is the dividing powers. So, and don't get tricked. There's 2 ways to show it, right? You could have, gee, I think I may need to erase some of this. Let's try this. Yeah. Okay, there we are. what did I write around here? That doesn't. Oh. Um. Okay. So yeah, so you could have 12 to the power 5 divided by 12 to the power 3 in this sort of fraction form. You could also have it written that way, and those are identical. They're absolutely identical. So don't get tricked by the different forms that they show. Okay, yeah, they actually show one example over here. So we could rewrite this if you prefer a stacked format. -6 to whoa, -6 to oh, okay, well that didn't work. You know, I go away for a few days and then I forget how to run the smart board. Okay, um, -6 to the power 9 over -6 to the power -4. Now, if for something like this, the reason they put the brackets around the constant term is that the constant, that's to make sure that the constant, that you are aware that it's negative. Okay, that's really important, to include the sign if it's there, or if the sign was outside the brackets, then the exponent would only be applied to the constant, not the sign. So we have -6 to the power 9 and we have -6 to the power -4. Now we can just kind of skip ahead here and use the concept. It's funny, they introduced this idea, negative powers. Anyway, so in this case, we have -6, and we could say, well, that's divided by, oops, sorry, let's go back again. Just -6 to the power 9 times -6 to the power +4, because remember the rule that we're going to see in law number 3, we skipped ahead, is we have, oh, what did they do here? Oh, okay, I see. Sorry about that. I'm skipping ahead myself. They have a different way of solving it. Whoa. All right, well, let's try that again. So we have -6 to the power 9 divided by -6 to the power -4, which means that if you remember, we're going to apply the dividing powers. We're going to subtract -4. Now, this is where things get tricky, because remember that we're subtracting a negative number. So you have to write it this way, and then just do yourself a favor and put a -1 in there. And then in the next line, we can actually solve this, the second half here. -1 times -4 is going to be +4. Okay. Now, if you have a scientific calculator, you could always check that, right? You could evaluate each term and then do the division and just double check to see if your final answer comes out to be the same thing. Okay, so just something you can double check. So that's one way to do it. And of course, once you learn about negative exponents, then you get you'll learn the other way to do it. All right. So finally, a power to a power. When you have an exponent, a number with an exponent, a number, a variable, and then you take a power, then you just multiply them together. Okay, which makes a lot of sense. If we think of s squared to the power 2, what we're really writing is s squared times s squared, right? Well, and then if we apply law number 1, we have s to the 2 plus 2 equals s to the power 4, right? Which is the same as 2 times 2. Okay, so if you forget the power to a power law, just rewrite it as a simpler question. And just try and work it out for yourself. Write it with like a 1 and a 2, or 2 and a 3 exponent or something like that, and see what you get. Okay. Okay. So now the other 2 laws are just special cases. Oh, all right. Oh, okay. So there's 0 exponents. So and it's just basically anything to the power 0 equals 1, except this guy over here, 0 to the power 0. It's sort of like trying to divide something by 0. You can't do it. And it's not that, it's just undefined. That's it. Okay. You just don't do it. Okay. And the further you go in math, the more you're going to sort of run into this sort of thing where there's some operations that are undefined. And in some cases, we can work through it. We have tools to work through undefined things. And you get some weird results sometimes in math where you have to do operations that wouldn't normally be legal. You can sort of, as I say, work around it. Okay, so if you're interested in that sort of thing, just keep going in math and you'll see it. Now, so zero, anything to the power of zero is just zero. You can remind yourself if you get something to the power of zero, sorry, anything to the power of zero, let me back up. Anything with an exponent zero or anything to the power of zero is one. Okay, not zero. I said zero. Don't say zero. One. You can remind yourself if you just take a something to the exponent 0 on your calculator, anything, 2 to the power 0, and you'll see that it's 1. Okay. Now, you may wonder how they got this one. Remember that when you have the bracket to the power 0, what it really is 3 to the power 0 over 5 to the power 0. 3 to the power 0 is 1, 5 to the power 0 is 1, and 1 divided by 1 is 1. Okay, so that's how you do that one. Now, I don't know, the order of this is a little off because I think negative exponents probably kind of belong a little bit closer to the other laws because they're kind of helpful. So anything with a negative exponent, it says it gets flipped, but what it means is that you're going to take the reciprocal. You're going to take 1 over x. Okay, so if I have 2 to the negative 1, and if I take the reciprocal of that, I divide it into 1, then I'm going to get 2 to the power 1, which just equals, 1 over 2 to the power 1, which just equals 1 over 2. So that can be quite helpful if you want a positive exponent. Okay. So in a case like this where you have 1 over 3 to the negative 6, you can make that exponent positive by taking the reciprocal of 1 over 3 to the negative 6. And basically what it does, taking the reciprocal of something like that just literally flips it around. Okay, so you're going to end up with 3 to the power 6 over 1, which is just 3 to the power 6 in a case like that. Okay. And then now something like this, 3 to the negative 2 over 3 over 3 over 4 to the negative 2. Remember that we could rewrite this if we wanted to, like that. And then we're going to take the reciprocal of the 4, which is going to be 4 to the power 2 over 1 times 3 to the negative 2, which is 1 over 3 to the 2. And if I multiply those together, remember that when you multiply fractions, you just multiply straight across. So we end up with 4 to the power 2 over 3 to the power 2, which is the same thing as this. So we can just kind of skip right from that notation where we have the negative exponent, flip or take the reciprocal of both of the numbers inside the bracket, the fraction, which the effect of it is just to flip the whole fraction upside down and give us a positive exponent or change the exponent. Okay, so that can be quite useful depending on what you're doing. Okay, so there we are. Now, when you're doing these types of real lengthy, kind of ugly expressions here, I would do it in a kind of a step-by-step way, kind of the way they show it here. Remember that you're multiplying. That's what the brackets mean here. Okay, so you sort of gotta watch it. It looks like it might be like a polynomial or something, but these are actually just individual terms. Okay, they just have, they're all joined together by multiplication. That negative sign in front of the 4x squared, that's minus 4x squared. Okay, so in this case, you just multiply everything together. We have, now, you know, they did the two constants together, and then for the x, I have x to the power 3 times x to the power 2. We're going to add them together. Then I have y to the power 4 times y to the power 6, and again, we just add them together. Okay. Likewise, down below, we're just going to take the square of each term inside those brackets. So I have 2 squared, I have x squared. Well, they said 1 times 2. All right. So basically what they're implying here is that this is 2 to the power 1 times x to the power 1, which is y times y to the power 1, and then they're applying the first rule, the first law. Okay? Sorry, the power of a power law, third law. Okay, so then they're multiplying these out, and it makes sense to do it that way. Okay. So what they did then, they took the first step, then they consolidated everything, and then for this to go from the second step to the third step, they used the rule where if I have 20x to the power 5 and I'm dividing it by 4x to the power 2, I'm going to divide the constants. 20 by 4 is negative 5, so negative 20 divided by 4, negative 5. And then x to the power 5 divided by x to the power 2 is just x to the power 5 minus 2. Okay. Another way to look at it, if you want to look at it this way, and this is just optional, so if you like the way you're doing it now, it's fine. The way I sort of visualize this as I'm going through, if I'm solving something like this, I'm going to say, all right, I have an x to the power 2, that becomes a 1, and that becomes a 3. Basically, I'm canceling out 3 x's right there. Right? That makes sense. And then, that becomes the power 8, like that. Okay. And actually, I cancel out the whole thing. And then the 4 goes in there once. Yeah, those become 1s. And then that becomes, negative 5. All right, so there's different ways to think about it, but in the end, we get the same answer. Okay. Be negative 5x. All right, so just work through those. Now, we're looking for your understanding, your demonstration of understanding of the power laws. So, if you got your work back, these were some fairly complicated questions that they gave us in the key questions. So if you get your work back and you got a few of them wrong, you'll probably notice that I just put an X through it, right? If you made a little mistake in one of the laws, it's not really a big deal. What we're looking for is kind of, do you have an idea of how to use them? Okay. All right. So that's pretty much it. Yeah, some of these key question ones were pretty brutal. Oops. But you can work through it one step at a time, which is the one. Yeah, this monster right here. So you've seen how we do it, right? So the first thing for this power to a power, I'd apply that one first, right? Then multiply the two together, because otherwise, if you try to do it a different way, it's not going to work. Okay, so it's a little bit of you have to recognize that you have to do power to a power first. Okay. All right. So that's anyway, that's key question 4. That's lesson 4. Now lesson 5, just exponential equations. And so this one is basically a matter of recognizing an exponential function, and this is really key. It has a variable, okay? A variable in the exponent. Okay, that's really how you recognize an exponential function. Now, in terms of what they look like, they're always going to cross the y-axis at 1, and that has to do with the fact that when the variable is equal to 0, remember that evaluates to 1. Okay, so yeah. Okay. And yeah, so it's all going to go through 0 and 1. Okay. And so if b is greater than 1, the graph's going to go up and to the right, and if b is less than 1, it's going to go down and to the right. They always go to the right, just whether it's going to go up, right, or down. And it really just depends on the value of B. Okay. And of course, the graph never goes below the x-axis, okay, of this type of function. Okay. Okay. Okay, so yeah, so it shows you a few examples, and then I think uh, we did an example in here, some tables, and that's pretty much it. Okay, so we want to recognize the exponential functions. We're looking for something that has a variable in the exponent, not a variable in the base, but a variable in the exponent. Okay. Okay, so then I think the rest of this was pretty straightforward. Okay, so that was the end of Unit 1. And as always, if you have some questions about the material, you're welcome. I encourage you to contact me. You can send me your questions by email or leave me a Facebook message or something. Okay, and I'll get back to you. All right, so now Unit 2, we learned about two sort of related things. It was simple interest, so how the simple interest formula works. And simple interest is not really used all that much in finance, but it's a good way to kind of get started, right? It's the sort of interest that you would probably use if you're gonna, lend your cousin $5 or something, your little cousin $5 for a couple of weeks. It's a very simple kind of interest where basically you tell them, I'm going to lend you $10 and you have to pay me back $11 in 2 weeks, right? And if you don't pay me $11 in 2 weeks, it'll be $12 in 3 weeks, something like that. That's simple interest where, the compounding period, the interest is not compound. Okay? So the formula is I equals PRT. You do get that on the final exam. However, you don't get the this part, so you'll have to know that part. Okay, you will get the formulas, so don't worry. Also, you don't get this part, so you'll have to know like how many months are in a year, how many days. We use 365, 52 weeks in a year. That and being able to go from months to years to fractions of years. Remember that for the simple interest formula, the time is always in years. So it could be a fraction. If they say 6 months, well, there's 12 months in a year, so 6 out of 12 months is 0.5 of a year. And so that's what you use, 0.5. Okay, so if you've sort of forgotten that or you're getting a little rusty, take a look at this chart right here. They show you some good examples. This is page 2 of your Unit 2. All right. And so then we did some calculations with simple interest. A couple of little things for the percents. We have to convert them to decimal before we use them for the interest rate. So percent means per 100. So all we do is we just take the 5.5 or whatever the interest rate is, divide it by 100, and we're going to get a decimal number. Now, a good tip for you to remember is that when you're convert a percent to a decimal number, if it's less than 10, it'll be 0.0 something. Okay, so you only get into, it's only point something if it's 10% or more. Okay, and most of the interest rates we work with are less than 10%. Okay, by the time you get into 15, 20%, 30% interest, you're talking credit cards, and they use compounding interest, daily compounding interest. All right, so we've seen how to do that. Just refresh your memory on those. These simple interest questions can be fairly straightforward, so that's where you want to focus. You want to get those relatively easy marks for this sort of thing. Okay. All right. Now, yeah. So I think we have that. Okay. Now, the other thing that you need to know as, yeah, we got I equals PRT. Sometimes you need to rearrange that formula. I assume that your algebra skills are up to that, where you need to solve for a different variable, the P. You can solve for the R or the T. Sometimes what they ask you to do. Okay. And that's about it. Um, Now, it's sort of simple interest is an application, you know, and it basically shows it's a linear relationship. That is that the equation, if you graph it, I, over t, it's always going to be a straight line. Okay, and so we call it linear or a line relationship. Okay, and the reason for that is that linear equations change for each time you change the variable. They go up. If you change the say the t goes up by 1 every time, then the I value will also go up by a constant amount. Okay, and that's what the definition of a linear relationship. Okay, so the way that we figure this out is by using the what we call the differences. Okay, so for each month, now remember these have to be in a sequence. They don't have to be going up by 1, they can go up by 2, but they all have to go up the same amount. So then you'll work out the interest for each period. So you're basically going to you're going to work out the I for a given t value, right? And your t here, by the way, this is month 1, right? So this is 1/12, right? And then for here, for month 2, now they're doing the total interest earned. Yeah, okay. And what we find out is that, yeah, so for month 2, they're just working out, yeah, this is the total amount. Okay. Yeah, just trying to sort out what they're, yeah, and so this is 2 months out of 12, and so on and so on. Anyway, what we find is that the difference between these two values, that the difference in I value month to month is a constant amount. Okay, and you check a couple of them. You really need to check 3 to make sure, but once you see that they're all constant, then you know you're dealing with a linear or constant formula. Now they kind of showed a graph here because they stretched out their graph so much, and they have such a tall scale. It's a linear equation, but it's not really obvious that it's linear. A more typical linear equation would look something like that, where the line has a substantial slope to it. Okay. Okay. So if you're asked to draw yeah, if you're asked to draw one of these graphs, you put your time in months, and depending on what it's going to be, it's either amount owed, right? Yeah, or total interest accrued. Either way, it'll be the same thing. Okay. So basically, the amount is going up by the same amount every time. The interest is going up by the same amount every month. Okay. So that's pretty much it for question 6. Try a few of these types of questions here where you're going to plug in the missing information. Okay, make sure you did all right on those on your key questions. Oops, sorry, this sort of thing. Okay, a good strategy for studying to go through all your key questions, just kind of review them all. The ones where you did really well, just sort of look them over. But where you had some problems, I would suggest that's where you focus your studying. That's where you're going to get your marks. Okay. All right. And I think that's pretty much it. Yeah. Okay, so make sure you're able to do some of these questions right here. All right. Now, lesson 7. Now we're on to compound interest and exponential growth. Now we remember that exponential growth is some number to a variable, right? For an exponential growth, the variable is in the exponent. Okay, and indeed, the compound interest formula, which is what all banks use, it's what all credit cards use, your mortgage uses it. Okay, this is the basic formula for compound interest. A, which is the amount of the investment, equals P, which is your principal, times 1 plus I to the power n. So n is a variable, okay, n is the time, and you see that it's in the exponent, which makes this an exponential um, equation. Okay. So in this case, I is our interest rate. We express it as a decimal, but keep in mind it's per compounding period. Okay, per compounding period. So we have to be careful. If it's compounded weekly, then we have to divide the interest rate, which is expressed as an annual rate, by the number of weeks in a year, or um, or that's it. Basically, we have to convert it to a fraction to the number of compounding periods in the time that we're calculating. Okay, so if a compounding is monthly, right, we would then typically divide the interest rate by 12. If it's weekly, we would typically divide the interest rate by 52. If it's daily, so we're talking a credit card here, then we're going to divide the interest rate by 365. So we usually leave it as a fraction when we're doing that. It makes it a little easier to understand. So if our interest rate was 5%, right, compounded daily, okay, then typically our I is going to be 0.05, which is that converted to a decimal divided by 365. And we're just going to leave it that way and plug it right into our formula in the I category right there. Okay, and that makes it easy to mark for me, and it also makes it easier for you to kind of review and double check, right? Because if you're kind of reading over the question, maybe the next question or the next part of it, okay, we increase the interest to 5.5, then all you really do is just have to go and change one number, right? Or maybe we change it from weekly or daily to weekly, then you just have to go and change one number, okay? And n, now our n value, which is the exponent, that is the total number of compounding periods. Okay, now they give you a sort of another way to think about it, but what it really comes down to is, let's say it's 5 years of monthly. Oops, 5 years monthly compounding. Okay, so what are the total number of compounds? Well, it's 5 years times 12 compounds per year. So, okay, it's going to be 60. That's what our n value would be, right? So you work out the total number of compounds in the investment, right? If it was for 5 days compounded daily, then our n would be 5. That's one of the few times we don't multiply by a number of years. And I think there's a question there where it's kind of in, I think the key question there might be a kind of a little trick question like that. Okay. So it's make sure that you understand that the n is the number of compounding periods. Typically, it's the number of years times the number of compounding periods per year. But for investments that are less than a year, you got to take a look at it. If it's monthly for 6 months, then it's just 6, right? One compounding period for each month. Okay. If it's less than a year, you sort of have to calculate the number just a little differently than we used to. Okay. Now, you see here the table. The one thing they didn't do is biweekly, 26 per year. That's just helps you with the number per year. I said quite often in the course, you need to know this. You need to be able to recall it fairly quickly. Okay, we don't give you that in the final exam in the reference sheet, the formula reference sheet. Not quite sure why. Anyway, I think pretty much sort of expected to know that. So anyway, this will help you as you're doing these types of questions. Okay. So, and you can try some of these. I've always recommended that when you go through the questions, in your process of understanding the question, you can write the variables This is this is part of our R. It's not exactly our R because it's going to be 0.083 compounded weekly. So that means that our I, sorry, not our I is going to be 0.083 divided by, there's 52 weeks in a year for 10 years. Now, I kind of skipped ahead a little bit there because if it had been less than a year, then this would have been wrong. I would have had to, actually, no, that would have been right. Sorry. It's the N that would have been. So now our N in this case is going to be 10 years times 52 per year, 520 compounding periods. Okay. Yeah, it's those compounding periods where you're paying interest. So every week they calculate interest on the outstanding balance. Okay, this is why when you have a mortgage, okay, and they give you an annual pay down option, that is the best thing you can do to pay that mortgage off early, and it makes a huge difference. So you get a 20-year mortgage and you're paying, a certain amount. Once a year, most of the banks will let you pay 10% of the original, up to 10%. Now, that can be a stretch, okay, but it can be very, very useful, help you pay that down faster. Because what you do is you take away 10% of the outstanding balance, boom, for all of the future compounding periods left. Okay, so each compounding, they're still going to calculate the same monthly payment because that's what you're locked into. But the difference is that there's less interest accruing. And so they will apply the remainder after they've covered the interest, which is less than the original contract. They'll apply the remainder to the principal. And that helps even more because then on the next compounding period, your principal is eroded that much more than it would be. It really is a beautiful thing, and you can change it like a 20-year mortgage. You can cut it down to I think less than 10 years if you keep paying those 10%. It's tough. It can be really tough, and like I know I'm trying to get. I have a spring one coming up, and it's sort of wondering how much craft dinner I can eat. All right, it's all for the best. So now they give you some examples here so you can go over these and make sure that you understand the different terminology that they use. So in this case, remember that the compound interest formula, unlike the simple interest formula, the simple interest formula, I equals PRT, we work out the I, and then we have to know that I equals A minus P, right? Or A equals the principal plus the interest. So the amount of the investment or the loan, the total amount that we pay, the cost of the loan, is the principal plus the interest you paid. Okay, so for simple interest, we work out the I, and then we have to calculate the A if we need it by adding the I and the P together. However, for the compound interest, the formula gives us the A. So if we need to know the I, we're going to have to work out the I from subtracting the principal from the total amount. Okay. So determine the amount when the investment matures. Now, this is something that a little later on, they may ask you something like, what is the cost of a loan? Okay, so in this case, they're going to say amount because it's an investment, so that's money that you get, but they'll call it the total cost of the loan when you are borrowing money. Okay, so but it's the same terminology. And then how much interest does it earn? Okay, so that's a separate thing, and for that you have to use this I equals A minus P formula. Okay, so do a few of those. Make sure that you can get them queued up. Now remember, you get marks for setting it up. Okay, so let's, if you're having some problems with working out these formulas, but you're getting it set up, you're still going to get some marks because we're looking for an understanding of the ideas behind it. Okay, so there's a difference between being able to set up the equation, okay, which is demonstrating knowledge of the course material, and being able to calculate, move all those numbers through your calculator, which is a skill that you may need to practice. Okay, so you'll get some marks for just setting it up. So don't leave anything blank. on the exam. Even if you can't even think of what numbers to put down, what formula to use, write something. Explain what you were thinking. Don't just skip it. Okay, you get some marks. Okay, so tied to the compound interest formula, then, this is an example of exponential growth. Okay, because the 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 n is over eager here. In the equation, the formula, notice that we have n, and that is the time. And so that is a classic example of exponential growth. Okay. Which exponential growth is good if you're investing, and it's terrible if you're borrowing. Okay. Oops. Okay, I think I just somehow skipped right past the. Oh, okay, it was right down here. Okay. So here we go. It's kind of showing you, and they put you through this exercise to basically work out that the amount is going to increase by a different amount, by a different value every time, and it's going to grow over time, right? So the first difference here is 8, and then it's 8.64, and so you can see that it is not linear. They're not constant terms, and I mean, that just from the exponent. But anyway, if you work it out, you'll see that it's just an example of exponential growth. Now, again, they've used a kind of a weird scale here for this graph. I got to redo these. But basically, the exponential growth is going to be like that, something like that. Now, where it crosses the y-axis, if it's just a straight exponential function with a variable, it's going to cross at 0, 1. But since we're multiplying it by something, it's going to cross at that, whatever we're multiplying it by, the principal, basically, p. There you go. Okay, that's where it's going to cross. Okay. So imagine if you're investing money at compounded interest, right? And then look at that. I mean, you're going to retire and you're going to be rich. Well, assuming that you're investing, some modest amount of money. Okay, assuming you can. Assuming interest rates are still fairly high. Okay. The problem is that if you're borrowing money, it looks the same way unless you start paying it off. Okay, and this is what a credit card bill can look like. Okay. All right. So we got that, and there we go. So it's useful when you're working on these types of questions to write down the formula you're going to need. Okay, that'll kind of help you. Sort of help you organize what information you need to extract from the question. Underline things, right? Compound. As soon as this is compound interest, you're using A equals P times 1 plus I to the power N. If it's just simple interest, then you're using I equals PRT. Right now, this sort of thing, CSB, Canada Savings Bond, doesn't really matter. You just have to understand it's an investment. And, Canada Savings Bond at one time were a pretty big thing because they were the biggie that the government was promoting. Less so now. There's because every bank offers GICs and term deposits and things, and you can just get those even online. I noticed the other day my bank offers it online. You just go in and tell them what you want. So with CSBs, there was a certain time you had to get them at a certain time of the year, whereas GIC is good all throughout the year. So the things that maybe we used to use to make money, the times change. So it's a good idea to kind of talk to your bank or go on their website and find out what's available. Okay, there's a lot more ways to make money these days. So we got to, as long as you know that that's an investment, and then they give you the annual rates. Now, don't 4.25%. It's going to be 4.25%. Now, how did I know that? Well, if I didn't have it memorized, I just 1 divided by 4 is 0.25. Okay, and then you would just add that to the whole number. Okay, and then the 7-year term. So you have to be able to work that out. Okay, And this is annual compounding. So your number of compounds per year is 1. Okay, very unusual. Okay. All right, so there you go. And this is the sort of thing where if you set the first question up, right, 6.75 compound annually, then the second question can be almost identical. Your calculations can be almost identical, but you just change the numbers in a couple of places, right? So it's mainly, in this case, it's going to be your I. Your first I is going to be 0.075 compounded what? Annually. So that's 12. That's for your plan A. And your I for plan B going to be 0.06. 0 doesn't really. Divided by compounded quarterly, so that's 4 compounds per year. So you see that, and that's the only difference. All your other numbers, your n's, no, your n's are going to be different as well. All right, well, let's see here. N, in the first case, it's 1 compound per year times 2 years, which is 2. That's your A. And then here, it's 4 compounds per year times 2 years. So your N is your NB is equal to 8. So yeah, so there are a couple little differences. But once you get those, then you're ready to plug them in, okay? Where you get your marks in a question like this is this part here, okay? I understand, you're cranking away in your exam, mashing that calculator, trying to get it all done in a rush, okay? So if something goes off the rails while you're doing all those calculations, that's not a huge deal, okay? It's what I want to see is you lay out the question and get it all queued up to be solved. Okay. Okay. So yeah, so as soon as you see the word compounded, you know that you're dealing with compound interest. All right. And I think that's it for that lesson 7. Okay. So we're going to look, and we just got a couple minutes to get started here. So we'll come back tomorrow and go through this in a little more detail. We're going to look at the compound interest formula in that there's different ways to calculate the different variables, right? The A, the P, the N. Okay, so we're going to look at different ways to do it. And one of the things we learned was a guess and check. And I don't know, I'll have to check the exam to see if there's a lot of guess and check. Whatever you do, don't spend a lot of time. If you get a question like that, just make a couple guesses and get close, and it'll be fine. Okay, you're demonstrating that you know how to do it, not necessarily you're going to get to within 3 decimal places of the exact answer. Okay. Now again, if you take some higher math, or if you're ever doing this for professionally or in the workplace, you're going to have software. Well, in the case of the higher math, you're going to have additional mathematical knowledge to help you solve some of these without the guessing and the checking. Or in the case of workplace, you'll have a piece of software that pretty much does the same thing. Okay, so that's it. So we know how to do the A. We could probably find the P from the A quite easily just rearranging the formula. But the guess and check, in order to find the interest rate or the N, I think certainly the interest rate, okay, we'll have to use the guess and check. Whoa. Okay, so we can take a closer look at that next time. Now, they did something that I don't necessarily like. Yeah, they worked out the I to be the actual I. Was that it? I prefer to have kind of the fraction, because we know the number in the denominator. We always know that. It's the numerator that we don't know. Anyway, it's just different ways of doing it. Okay. All right, well, we better wrap this up then for today. So we'll be back tomorrow, Wednesday, and we'll be back again Thursday, and we'll keep going on our review. All right, have a nice day. Bye now.